Good day. My name is Francis R. Santos and my partner is Edward M. Nabong. We are the reporters of Module 10 and our topic is branch and feeder calculations. Let's proceed. Branch circuit is found in National Electrical Code and it reads the circuit conductors between the final overcurrent device protecting the circuit and the outlets. In practice, a branch circuit consists of the source of the voltage, the wiring, and the load. And also we have the feeder circuit. It's found in National Electrical Code 2 and it reads all circuit conductors between the service equipment or the generator switchboard of an isolated plant and the final branch circuit overcurrent device. Conductors from on-site generators and transformers are also feeders, not service conductors. Service conductors extend from the utility source to the service disconnecting means. And also have overhead service. This service is normally tapped onto the utility lines at a mutually agreeable point at or beyond the property line. The service may tap be a connection on a pole with an overhead service drop to building, an underground service lateral to the building, or a connection to an underground utility line to the building may be run overhead or underground. Depending on terrain, other factors, the cost of overhead as compared to underground installation in the range of 10% to 50% only. We also have service entrance switch. This service switch is only for disconnected. The purpose of electric service switch is to disconnect all the electrical service in the building except emergency equipment. Thus, in the event fire, no electrical hazard will face firefighters. It is therefore obvious that disconnecting apparatus must be located at a readily accessible spot near the point the service conductors enter the building. Electric metering. Metering must be provided at either the utility or the facility voltage and at either the service point or inside the building, which must be accessible to the utility meter reader. Generally, for a single use building or a building where electrical energy is included in the rental charge, only a single meter is necessary. Main distribution panel. The main distribution panel or switchboard and freestanding assemblies or mounted assemblies of switches, fuses, and or circuit breakers, which normally provide switching and feeder protection to a number of circuits connected to a main source. Panel and cabinet mounting. Panel boards are classified as flush type or surface type. Flush type panel boards are those that have the trim and doors practically flush with the finished surface of the wall. Surface type panel. A project into the room, the cabinets being controlled to wall or columns. Also used in industrial plants. Panel boards. A panel board serves basically the same function as a switchboard, except on a smaller scale it is accept relatively large blocks of power and distributes it in smaller blocks like switchboard. It comprises main fuses to which are connected circuit protective devices, breakers or fuses, which feed smaller circuits. The panel board's level of the system is usually the final distribution point, feeding out to the branch circuit that contain the electrical utilization, apparatus, and devices such as lighting, motors, and so on. Panel board are described and specified by type, bus arrangement, branch breakers, main breaker voltage, and mounting. A typical description might be lighting and appliance panel 3-phase 4-wire 200 mains Mains circuit breaker 225 ampere frame, 150 ampere trip.
Feeder is installed under the following consideration. Service drops may generally be not less than number 8 AWG, and service entrance conductors or underground service conductors not less than number 6 AWG. Number 2, it is recommended that a minimum of 100 amperes, 120, or 240 P service be provided for all individuals residents. Number 3, no service switches smaller than 60 amp or circuit breaker frames smaller than 50 amperes shall be used. Number 4, in multiple occupancy buildings, tenants must have access to their own disconnect means. Number 5, on large installation, each floor is provided with one feeder. Number 6, in small installation, one or two feeders is satisfactory. Number 7, feeder for electrical motor shall be independent and totally separated from the light circuits. Number 8, feeders requiring more than 50 millimeter diameter conduit pipe should not be used. Number 9, feeders shall be subdivided if there are several bends or offsets on the line. 50 mm conduit pipe is the largest diameter that could be economically used. Number 10, feeders radiating from the distribution panel shall be provided each with a properly rated switch and circuit breaker. Number 11, good practice dictates that feeders and main shall be installed inside a conduit pipe as it carries high voltage that requires special protection. Branch circuit is based in the following considerations. Number 1, the installation must be flexible to accommodate all probable pattern arrangement and location of the loads for expansion or future development. Number 2, the reliability and efficiency of the service is dependent on the building wiring and utility service. Number 3, from the code, the maximum lightning load is 100 watts per light outlet, a maximum of 180 watts per small appliance outlet, and dependent on the load's special outlets. For motors, the ampacity should be 125% of the full load current. Number 4, emergency power and standby power must be provided for selected parts of the system. Number 5, equipment failure must be detected and corrected automatically. Number 6, the code requires that all residents with 5 or more 2-wire circuits have a minimum of 100 amp of 3-wire service. Service will disconnect for 100 amp service would be 100 amp. 2-pole and solid neutral switch fuse at no more than 80% of rating, or 80 amperes. This is usually written 100 A, 2P, and SN 80 AF. This service is used principally for residences, small stores, and other occupancies where the load does not exceed 80 amp or 19.2 kVA. The load calculated is shown below. 240 times 80 is equals to 9,200 VA or 19.2 kVA. Number 7, each appliance, device, lighting fixture, or other load is taken at its nameplate rating, except certain kitchen and laundry appliances for which the code allows a demand factor. Group and ground fault protection. An ancient fault within an appliance can connect the metal case of the appliances to the line. This may readily occur with such common devices as an electric drill, clothes washer, dryer, or food mixture. To eliminate this hazard of electric shock, appliance housing is grounded to a cold water pipe. The plug is 3 wire, 2 wires connected to the appliance and the third wire to the housing. Some reasons for grounding are: number 1, to prevent sustained contact between the low voltage secondary system and the high voltage primary system in the event of an insulation failure. Such contact could cause a breakdown of the secondary system insulation and severely endanger the system users. Number 2, to prevent single grounds from going unnoticed until a second ground occurs, which will extensively disable the secondary system. Number 3, to permit locating ground faults with ease. Number 4, to protect against voltage surges. Number 5, to establish a neutral at zero potential for safety, and for reference, this neutral must never be interrupted by switches or other devices. Connected to ground only at one point, the service entrance, and is color-coded white or natural gray for easy recognition. Emergency or standby power equipment. The equipment involved in both emergency and standby is similar. However, the use is different. Emergency system provide power and illumination essential for safety to life and property. For instance, emergency power for exit lighting and degrees lighting in place of assembly, plus power for equipment necessary for safety such as elevators, fire pumps, and extensive system in healthcare facilities. Standby system provide power to selected loads in the event of failure of normal source. These systems are primarily intended to protect against property damage or financial loss and are not involved with safety consideration. Water and sewage treatment plant use this. Circuit protective devices. In order to protect insulation, wiring, switches, and other apparatus from overload and short-circuit currents, it is necessary to provide automatic mean for opening the circuit. The two most common devices employed to fulfill this function are the fuse and the circuit breaker. The general rules in installing overcurrent devices are: number 1, overcurrent devices must be placed on the line or supply side of the equipment being protected. Number 2, overcurrent devices must be placed in all underground conductors of the protected circuit. Number 3, all equipment should be protected in accordance with its current carrying capacity. Number 4, conductor sizes shall not be reduced in a circuit or T1P unless the smallest size wire is protected by the circuit overcurrent devices. That's all. Thank you.